How's it going, people? How's it going? How's it going? It's going. Well, I'm glad it's going. Whoops. Why do I keep putting 32s? See, here's the thing is we're, see, I don't want to have to make unsigned and pointer versions of this. But first things first, we'll make it work, and then we'll figure out what to do. Do our allocators access some global data pointer? I mean, your allocator is whatever it is. Your allocator stores its memory wherever it is stored. So C++, I think, does a template nastiness. We could do that here, but I don't know. We'll make this work. And then we'll see if we want to try to do template nastiness. Just wonder because I don't pass them in by reference. Well, the allocator data right now is just a void pointer because we don't know how big your data is or whatever. So it's a void pointer, and then you dereference that to do whatever you want. Okay. Well, I think we'll probably already barf on unknown intrinsic, right? No, okay. If we don't call the intrinsics, we're fine. Let's make a test program. Let's get rid of these. It's been a while since I did threads, so let's look at how to do threads. Num threads is going to be 10. Num iterations. Okay, so we're going to say counter is 0. And thread proc is going to be 4. Okay, you can see where this is going. This is going to be bad news. And then we're going to say counter is correct number is counter num threads times num iterations. And let's call this correct. Okay. Well, what is my thread proc? Takes a pointer to a thread. Returns S64. Okay. So we call thread init on the thread with thread proc with temporary storage size. I don't know. We don't need that. Just do that. Okay, great. Okay, we'll just create these in a loop. Thread start. We want to start them as close as possible to each other to get race conditions. We're going to start all the threads. Let's just do it like this. Just do it on one line style. Okay. And then we want to wait for all the threads. For threads while threads dot no. I was going to try to stay away from having a dynamic array, but whatever. Live threads is fine. So we're just going to add all these guys to live thread. like just my thread pool here, I wanted it to be tightly packed because I'm, performance programming. Okay, so for live threads, if thread is done, remove it, right? While live threads and then sleep. Where's our sleep? How do we sleep? Oh. Sleep milliseconds. We're just going to do that, okay? So we've got some threads. We init them. We start them. Do we need to thread stop? No. And we're just not going to bother destroying the threads. Okay. So the whole point, all we're trying to do is spin up a bunch of threads that do some bullshit, that add one to a counter incorrectly because there's going to be a race condition and the answer comes out wrong. So we're trying to make a program. Well, we're trying to make a program that'll be correct if num threads is 1, and that'll fail if num threads is greater than 1. You get it? You get it? Okay, well, I guess thread is done doesn't do that. All right. Well, that's not very good. Okay, well, we failed one time. Okay, we're really not failing as much as I really wanted to. Maybe it's not enough iterations. Okay, there we go. They were just finishing their loop too fast. Boy, these numbers are much smaller. They're like an order of magnitude too small. Okay, so you see the problem. You see the problem. If we change this to 1, hopefully it'll work. Okay, great. As soon as we even change this to 2, we have race conditions. Whoops. See? See? Okay, great. So let's print more information. Okay. So whoops. Oh man, it's that, but the Heisenbug is still in there after all this time. I just haven't bothered to fix it. Okay. So the whole point of what I want to do now is to make an intrinsic that helps us fix this without having to use a mutex, right? So one way to fix this, well, we could do the following. We could say mutex is a mutex, right? Init the mutex, and then here we say lock mutex, unlock mutex, right? So now we're, oh, well, let's put our threads higher than 2. We're correct, but we're frickin' slow. Look how long that takes to run. Wouldn't you much rather be fast and incorrect? So, okay. So that's one way of solving this problem. And this is how all the Java programmers do it. And all the JavaScript programmers probably don't even understand. So we want to do it a different way using a machine language instruction. And so we shall. If you make the counter store the value as a temporary, then sleep the thread for a few microseconds, then assign the increment after waking, you should have a more reliably incorrect program. That is true. The problem is that that's not going to work very well when we try to use our intrinsic, because the thing we're going to do, we're going to implement a compare and swap. And the thing about compare and swap is, you use the old value to validate that you didn't screw up the thing. And if that old value goes out of date, then you'll starve eventually, right? So, or you'll die, you'll infinite loop. So we don't want to actually do that. You use JavaScript at work and you totally understand this, rude. Well, I don't think, 100% of JavaScript programmers. Actually, it's the Python programmers that don't understand this. I shouldn't have said JavaScript, right? It's Python. The fabulous single-threaded language. Starving and dying forever does sound bad. It is almost as bad as crossing the streams. Okay, so we're going to comment out the mutex. I was just doing this to illustrate like how you might solve the problem, right? So there's another way that you would solve the problem, which is well, we could do this. Imagine that we were doing a more complicated thing. Anyway, so we say new counter is counter plus 1, and we'll say compare and swap counter so we're reading the value of counter. We're only using that to generate new counter, right? And then, right? So what this says is at the machine instruction locked forced to be synchronized level, store in counter new counter, but only if the current value is equal to old counter, right? And so we're still using a locking instruction, but it's way better than a mutex. Now the problem is this by itself may succeed and may fail. Okay, so this isn't good enough. We're going to say while true, and then we say if, let's call this success break. Okay, so we keep trying until we succeed. Now we're still going to fail a lot because these are pretty tight loops, and we have in fact, I don't know, let's reduce the number of threads to like 3 for now. I forgot my returning bool. So this returns bool on success. And if you know C++, this is exactly, I mean, this is just a standard, compare and swap is a standard computer science concept. And there's a C++ one in like standard atomic. Do I have it pulled up? No. This, well, they have this weak and strong bullcrap. As far as I know, nobody ever uses the weak ones because they don't work, right? They don't do what you want. But so, yeah, they're doing something about something else, like a memory order. Yeah, we're not gonna add that complication. What we're doing is we're just implementing something that will map in native code. It'll map to this comp exchange instruction with a lock prefix, right? We're going to have to use this for now because in bytecode, we don't have, as far as I know, a way to emit that instruction in a reliable way. So we're going to have to use C++ here. So I'm going to have to understand what the hell this memory order thing is. Oh, but it's got a default value. So I guess I just will try calling this one. Anyway. To solve this problem using mutex is to use temp variable to increment without locking an after loop and do counter plus equals temp. Yes, totally. Like you're starting to optimize for this specific problem though. Like in reality, you wouldn't increment a variable at all because you know how many iterations there are, right? In reality, you would just mutex it and add 500,000. But that's not the point. The point of this program is to stress test our intrinsic that doesn't exist yet, right? But totally, yes, if you wanted to do it the mutex way and didn't want this to be that slow, you would not do the same thing that I'm doing here. Strong is when you actually want to know about and handle contention. But you can't, I mean, loop until it succeeds doesn't make any sense in this case because it's never, if it doesn't work the first time, it is literally never going to succeed, right? Because my computation is now stale and the counter will never again reach the value that I'm testing for. So, I don't really, maybe there's some small set of algorithms on which those weak versions make sense, but it doesn't totally make sense to me. Is this sort of like software transactional memory? I'm not super big on software transactional memory, so I can't tell you exactly. I used to be excited about it back when it was like a new idea. Like software transactional memory is like much more involved and higher level. This is like a very low level. This is just like, look, the CPU provides some instructions to help you with parallelism. So let's give the programmer a way to use those, right? That's all we're doing. Okay, so now I'm trying to use this intrinsic, and it's here. So now we should get an error that our intrinsic doesn't exist. Yeah. So we're trying to use cast64, and the compiler's like, bro, I don't know what that is. So now we need to start implementing this. I think we only need one instruction, and then we're going to know from the register size, because we know register sizes in the thing, we're going to know which instruction to emit in the end. So let's make compare and swap. Okay. Someone on Stack Overflow. Let's read the Stack Overflow. Right. Yeah, so it's all about memory models. We're just not going to worry about weak memory models right now because they're hard to think about. We're going to do strong memory models, and because I think that's what people have stabilized on. If we decide that a weak version makes sense, we'll do it, but I don't know. Okay. So emit code for intrinsic. We're just going to keep spinning out our things. Actually, I think it's okay to do this. I don't think we need this cas8, cas16. Because like I said, yeah, we could just do this. So we're going to go dest value, dest old value register, new value register. Right? And then it really should be like dest register should be index result. Yeah. Oh, no, we need a return value. What do we do that before? Return register base. There we go. So we need that. Dest like in this one is called the result register, and I wasn't really using that as the result, or maybe that's not a result. I don't know. I'm just going to do it this way. Okay, compare and swap. Now, really? What? Oh, intrinsic compare and swap. compiler uses multi-threading. Is there any risk of non-determinism? What do you mean by non-determinism? Do you mean a non-reproducible build? Or do you mean a program that does different things? I don't think there's any risk of a program that does different things, or at least anytime we see that risk, we implement something to prevent it. But right now, the order in which we put the things in your object file probably changed. Yeah. If you wanted to enforce a reproducible build, we would probably have an option to sort those at a performance cost, you know, because, yeah. Okay, unknown instruction. That's great. That's what we want. Well, you know. So we need to implement this in C++ and in x64. And you know what? I think we want a much simpler program before we go back to our threaded situation, because really, if we can't like increment a single variable, we're not going to be able to do much, right? So we're going to do this. X is 0, old value is x, new value is x plus 42. Compare and swap. X, old value, new, no wait, new value, old value? What order does C++ do it in? Expected, desired, wait, what? That doesn't make that much sense. Oh, this is a member on standard atomic. Okay, that's why there's not another parameter. God. All right. So we compare and swap. Destination, old value, new value. Right. Success. Okay, so if this works, which it should, then we can uncomment this whole thing and see what happens. But first, we're going to do this, right? Okay. And we're even going to run main here at compile time. All right. So now, so we have two places. This is in the, we should put a new line here. This is in the x64, and this is in the bytecode interpreter. Yeah, let's put a new line. Put a new line. All right. We're fixing our new lines. Okay, so let's do this standard atomic bull crap. Like, dude, I've never used standard atomic in my life. I have no idea how I'm going to do this. I guess I have to cast something to standard atomic. Oh my God. Okay, let's just try it. Okay, compare and swap. We need these registers. Remember, we did memcopy, memset, and memcomp this morning. Compare and swap. Return. We're going to need this. I don't think I need to do this. But you know what? We're going to do it anyway for now. We're going to do it down here, and that's going to remind us to clean it up. I'm pretty sure that we don't need to do this. We'll, by the end of the stream, if I don't remember to take these out by the end of the stream, somebody remind me if you're still on. You can use the Scie version, which just uses volatile pointers. Really? What's the Scie version? Is it cross-platform or is it a Visual Studio function? What's the Scie version? Whoops. Wait, this is... Options. New value is record registers BC index B dot. Well, we don't know. We're going to have to break this out into 4 cases based on size. How do I know the type of a register? Aha. Value type is the type of index B. Assert size has been computed. This might actually not be true. Okay. Assert size equal to 1 or size 2 or size 4 or size 8. Those are going to be the sizes that we handle. All this garbage just to emulate this thing. All right. How's Huskers doing these days? Okay, so here's the Scie version. When we get to the point where we can use this, which will hopefully be soon. So these are the same as the C++ ones, but different. Why is the expected a pointer? All right. Anyway, this is the one I'm going to use. But first, we have to do this. Bull crap. And fight with the indentation and all. Okay, whatever. So if the size is 1, we need to okay. Just Emacs doesn't understand good ways to indent switch statements. I don't understand. It's just always bad. It's always bad. So we just want atomic compare exchange strong. Dest pointer. Okay. I don't know why it wants me to take a pointer here, but okay. Old value. Expected. And then new value, right? Okay, so this is going to be the same for all of these. What's going to happen is we're going to say auto old value equals registers BC index. At some point, it's going to be annoying writing all these emulations, and it'll be better just to switch to running machine code at compile time. It'll be faster too, probably. So maybe eventually we'll do that. All right. Anyway, old value is options dot U8, right? U16, U32, U64, right? New value is BC index B. Right? And we say result is this. Should have done that before I pasted it. Okay. Okay, so actually, I might keep this 0 here because I want this to be a well-defined 0 or 1. I don't know what these C versions. I don't know what underscore bool is. I guess it's fine, but we'll just be explicit for now. Okay. So we're going to have to include standard atomic.h atomic. Put that down here. I'm sure this is going to be a disaster. Cannot open include file standard atomic.h. Okay, well that's one way to have a disaster. Is it in a subfolder? Well, I guess I have to do the crappy C++ version. Windows has underscore interlocked compare exchange. I could use that. And I could just let the Unix people figure. Is there one on Linux as well? Because I would actually prefer to use that. If there's one on Linux, then we're good. I would rather do that than the C++ thing. Long, char, short. So these are all signed, but that's fine. Okay, so why do they all return the same type? These don't like return bool. And they take them in the opposite order. Anyway, interlocked compare exchange. Right, dest pointer, new value, old value. What do these return? So these are explicitly called 8, 16, etc. Return value is the initial value of the what? This is garbage. How do I know if it succeeded? Can I zoom in? Okay. How am I supposed to know? Okay, am I just being thick here? It returns the initial value. So I could manually compare that with the old value, I guess. right? I mean, that seems annoying and stupid. I guess that's useful because you could, in some cases, use that to make a decision about what to do. But it's also like it's outdated information because you're asynchronous. So like, it's hard for me to imagine how to use that productively. Yeah. So this instruction, oh, it does the same thing, I guess. Maybe our intrinsics should do that. What do you guys think? Like if people are returning that, I mean, maybe Windows is this way just because the instruction is that way. This actually gives you both, right? Zero flag tells you success or failure, and you get the old value. Okay, we're going to try using this. Okay, forget this. Okay, so what are these ACQs and RELs and NFs? ARM platforms. Okay, we're not going to worry about that stuff. Okay, so interlock compare exchange 8. Should have done it before pasting. Right, so it always returns the old value. Return value is the initial value of the destination pointer. Yeah. Okay. Okay. 16, 32, 64, 65. Nintendo 65. Okay. So we're doing this. Let's double check. Let's double check this other stuff. Okay. Destination. Old value, new value. So destination is A. New value is B. Result is index result. Yeah. And old value is options. Okay. Great. Great. Isn't this worth making your own in assembly? You can't do inline assembly anymore in Visual Studio. And the inline assembly would look exactly like what I'm doing, except it would be even more annoying. x64, so Visual Studio didn't ever do inline assembly once you went to 64-bit, as far as I know. Unless someone wants to correct me on that. But this wouldn't be worth inline assembly anyway. So where is this thing defined in? Okay, let's get rid of this weak sauce. In trin.h. Okay, I've got all sorts of problems in life. Maybe that'll help. Not much. Registers. Whoops. Okay, that's good. Interlock compare exchange 16. Char star to volatile short star. All right. See if I can leave off the volatile. Interlock compare exchange 32 not found. Is it just there's no 32? Mega 32? Yeah, there's no, so 32 is just the default. Okay. Wait, what? Long star, long, long. Now, I guess long is unsigned. Oh my God, dude, this is trash. This is trash. Okay. The other ones are signed, but this one is unsigned because Windows. Okay, 1522. Right, this was old. No, we're just doing this. Okay. Well, that's a thing. Success true, X is 42, but then we can't output the instruction. But there we go. There we go. Do we dare? Do eagles dare? Okay, that totally didn't. We're just barfing on the back end. Oh no, we're not. We're not running main. That's what's happening. There we go. Bro, check it out. We could thread. We could lock free thread. How many compilers let you do lock-free algorithms inside the compiler? Okay, so we need to now generate this bull crap on the back end. Yeah, so here we go. Intrinsic, what did we call it? Compare and swap. Okay. We're just going to put it straight in here. We're not going to even make a function. Okay, well, we have to do the same frickin' thing that we did here, though. Okay, this is totally redundant assertion. So there we go. And we're just going to printf that. I just want to see what, we don't have record. Like that. Register. Yeah. This guy gets a bytecode. Is that a global? What? Do we just have that? We do. We just have that. All right. Okay. We didn't. Why didn't we printf anything? Oh, we did right there. Size is 8. Okay. We should also do a test on different sizes at some point. Oh, we could just change the size of the counter. Let's do that. So counter is S32. Size is 4, and it still works. S16, now we're going to like overflow, so it's not going to work. Yeah. Well, it has to be big enough to hold the frickin' value. All right. So this is all fine. So we're going to add some bytes. What are they going to be? They're going to be the following. We want to do, well, can we do 64? We need a rex w. Yeah, we're just gonna do it differently each time. Okay. Size. We asserted size. You know what? We're just going to do this. And we're doing this because I don't want to deal with Emacs's indentation for switch statements. Okay, so size 1, 2, 4, 8. So all of these start with OF, right? 8 has rex w OF. How are these two different? They're not. These do the same thing. It's just that you're allowed to put a rex byte. I mean, that's got to be for register access, right? It's just like, look, you can get to the registers. But not for 16 or 32? You can only get to the extended registers in 8 and 64? Is that what I am given to understand here? Okay, so B0/R, what the fuck does that mean? Oh my God, I don't remember. I don't remember what the B0, B1. I mean, the B0 is the byte, right? But what's this /R there? Is that just a regular mod RM byte? This is what happens when you only look at these every 3 years. You have no idea what's going on. Okay, so B0 for 8. Right, B1 for 16 and 32. So like that /R must have something to do with how it knows whether it's 16 or 32. And then this one is OFB1. /R meant the register is encoded in the opcode. Oh, like you add the register value to the B0 or B1, or you OR it? Like what? I don't remember that. Okay. But there's like a mod RM byte, right? How did this work? I guess that just means mod RM byte. I don't know. Okay. Three and well, so old value goes in RAX. We're going to have to do that. Okay. And then It's like reading hieroglyphics, man. So you can only encode one register, and mod and RM should be 0. But there's 2 operands. That's what I don't get. You have to be able to encode more than one. There's 2 operands. Right? So if one is the pointer to the old value, and one is the new value. Right? I'm just going to go old value, new value. We'll put it into RSI maybe. It doesn't matter that much. RDI, DI makes more sense than SI, and RCX. So RCX is going to be, we're just going to do 8 first and make it work. How's that? And then once we make it work, we'll make it work for 4, 2, and 1. Okay, because we have to we're just going to use this. All right. Frickin'. Don't remember which one is that. We don't really need to extend. All right. The reason we're extending is just because we're just. Oh, we don't need a move extend, actually, because this is the 64-bit. I'm a dummy. I'm a dummy. We need the move extend for the other ones later. RAX, RSP. Okay. So now, which one is it again? Okay, this is the old value. Old value goes in RAX, so old value is in options. All right, so we get that. And then we do our thing. So now we need RDI and RCX. So Rx gets old value. RDI gets index A. New value is index B. And then we need to return something. So the thing sets the 0 flag. Actually, I could do this down here because we want this to be in common for everything. The thing sets the 0 flag. So we can do a jump if not 0. Oh, what a pain in the butt. What a pain in the butt. So what if I... Okay, we did this. Okay, and this is going to be common to everything. Okay. So it's in the 0 flag. How do I convert the 0 flag to a 1 or 0 that's the XOR of the 0 flag without a branch? Second operand is an implicit. No, because you need, look, the EAX implicit is the old value. You need 2 other operands. You need the target memory location and the new value. Oh, you were thinking of slash digit, yeah. Set NZ, I don't know what that does. Is that an actual thing? Oh, nice. So we're going to set NZ. And then we're going to sign extend it, even though we don't care. OF95 mod RM3 REX0, right? Okay, something like that. Actually, if we rex W this, okay. Okay, we're getting Fun. All right, so RexW OFB1. So I don't know if this is right. So the first thing we're going to do once we compile is we're going to look at the assembly output before we even try to run it, because it's probably wrong. This is MOV64, not MOV64. Okay. We're gonna go to main, and we're gonna make the very first thing, like before, be a call to this intrinsic, just so that we know where to find it without digging through lots of instructions, right? So we're just gonna go compare and swap. All right. Whoops. Okay. Hey, look, because we added 42, we fail now, but that's fine. That is fine. That's good. It just means we actually don't fail because we work. Okay. I should be able to just do that, right? Boom. Okay, disassembly. Compare and swap. RAX. Compare exchange. RCX, RDI. Are those in the right order? Oh, we need the lock prefix, by the way. Let's not forget that, because that's the whole point. Okay. This doesn't work, right? Like, this is not, like right now I'm doing this on a register, which is not what we want. We want, so first of all, we want these in the opposite order. Second of all, though, this shouldn't be 3, because we want to like dereference this guy. So we need our mod rm byte to be a dereference. And again, I look at this like every 17 years, so I have no idea. Okay, here we go. So 3 just means it's the register straight up, right? Here, here, here. So let's make mod be 0. How is our set NZ? Set NE, is that the same as set NZ? I guess so. Set NE OF95, set byte if not equal. Set NZ OF95, byte if not 0. Why do they have both of those? I couldn't tell you. It does not make any sense. Okay, so now disassembly. Okay, comp exchange. contents of RDI with RCX. Setni. So our RexW didn't change this at all. So you know what? We're just going to zero just for now. So we're zeroing A. We're going to put this in there and then do the move. Will it work? It's anybody's guess. You know what? Let's make a very simple test program. Let's say we're going to comment out our very sophisticated super program. We're going to compare and swap counter. And then we're going to say, we're going to print the value of counter, right? Should be 42. If it's not, then we're sad. 42 at compile time. 42 at runtime, baby. Baby. Okay, let's comment that out. So many things could go wrong right now. So many things. Like, we're infinite looping for some reason. We're never returning true. All right. All right, so success was true at compile time. Success was false at runtime. So we have to fix that. What did I do wrong? Probably just forgot to do it. I'm going to put no check-ins here, just so that I don't forget. No chicken. No chicken. Well, I mean, it said the zero flag is set on success, and it did increment it. So my setNZ is not doing, but it said setNZ AL. Anyone know? Anyone know? What could possibly, what is wrong with my set NZ? Or maybe it's this. What if I just want to return true? Let's test our return value path. Right? So we're just going to return 1, even if it fails. Okay, well, that works, right? If we change it to 0. Okay, well, so our returning the value seems to work. So what is not working is the 0 flag being set. Why would that be? I mean, we can look at the disassembly again to make sure, but I don't really think that the like if we succeed, the 0 flag is set. So we don't want set NZ, we want set EZ. I don't know why I thought of knotting it. Set Z. Right? I was the sheriff of Nottingham. It was not the right thing to be. All right. Well, okay, guess what? We incremented. We didn't add the lock prefix. Remember the lock prefix? How do we learn about the lock prefix? What does ZO mean? Opcode F0. It's got its own byte. Okay. Okay. We didn't succeed, but we got a better answer than before. That's weird. Okay. If we have one thread, okay, we know this works at compile time. If we have one thread, do we get the right answer? I hope so. Yes. Okay, if we have two threads. Yeah. So I'm not using lock correctly. I've never done this before, so this is Blue's news to me. Blue's clues. Oh. Let's put one of these. Let's just do a cast with 0 so we don't mess up our result. All right. Lock, compare, exchange, whatever. I mean, seriously. Maybe we're always returning success even when we fail. somehow. Shouldn't be, because we're always setting, like set z is set if 0, right? Well, let's read about lock. Well, I mean, that looks fine. Set z, set bytes if 0. All right. So it should be 0 if the set z doesn't fire, because I mean, I don't know what else I'm supposed to do here, honestly. I'm not sure how to debug this. Oh, zeroing the AX register is setting the Z register. Z flag. You're right. I had this same problem before, and I'm jet lagged, so I didn't remember it. We'll poop. Because the problem is, I mean, I guess we could put it in D. It's just we're using more registers than we need to, right? Like, I would rather whatever. We're just going to pollute more registers. Who cares? Thank you for catching that. That might have taken me a while to figure out. Okay, now it's totally broken. Again, we're never... Oh, you know what? I bet it's putting it in A again. So I think A is 0. So if you get this order wrong, it's still A. I was thinking about that before. I always get that order backwards. Maybe I should change the order of the parameters. Then I'd have to change everything. Bro! Look what just happened with 2 threads. Okay. Threads 10. Bro, no spamming. All right. The band hammer is coming out. What did I just thread? Well, you're going to have to watch the VOD. This is a test program. We are generating... We are doing an intrinsic for a compare and swap CPU instruction, and we just got it working. For the 8-byte case, we have to get these node chickens to work for 4, 2, and 1 bytes. So We're going to have to move extend these. Don't really need to move extend these, but we don't have non-64-bit destination moves yet. Okay. Okay, so move, extend, indirect. RAX, RSP, BC. It's so weird that we don't call register offset here, but we do in the other one. Okay. RCX, index B. I mean, really, this is the same for all these. Anyway, we're going to want to lock. And then compare exchange 32. OFB1. So it's the same, it's just without the rex byte. And then we fall through and do our thing down there. Okay. Yeah, I know that in part of Twitch culture, spamming a chat is considered fun and a compliment, but I want to try to preserve quality discussion. That's all. That's all. All right. So now, well, we're going to test this. And the way we're going to test it is just to go here and make it S32. Let's take out our mutex. The mutex was just an example. All right. It's not working. It's not working. Let's make sure it still works. At compile time. Yep. It's not working. Actually, well, even if we were overflowing, it would terminate. Let's cut it down for now, just to, yeah. Well, let's see what we did wrong. Let's see if the assembly makes sense. Lot comp exchange, RDI, ECX. That's right, right? Set EDL. Is it? Yeah. I don't know. Let's print success at the beginning. I bet this will say false. Yeah. Why? Why is even this one saying false? Okay, I must have really messed something up. So the whole idea is we do this stuff. Same thing, it's just without the rex W. Oh, wait, do we need... Is it assuming the pointer? No. So this is a 64-bit pointer, right? It's not gonna, yeah, it's not gonna think it's like a small pointer. I mean, we could tell that from the opcode, I guess. If you don't mind moving a constant to the register, you could use register AX. Yeah. Yeah, I mean, I'm not going to worry about that yet. I'm concerned right now with why doesn't this work. Lock, comp exchange, dword pointer, RDI. So it's using the full, right? It's using the full RDI. It's not using EDI. That's good. ECX. Now, for some reason, this compare is never succeeding, or this is failing, but this is exactly the same. So, like, this compare must be wrong? Wait. ECX, which we just put right there. Okay, what happens if I put this same thing here? Because, like, this should still work. Like a move extend, I mean, in principle, that should work. I just want to know if it does. So 64-bit. That worked. And now our console is attempting to index a nil value every time. Thanks, guys. Okay, so that works, and this is still not going to work. Why? What? I mean, this is now the same as these are the same, except this just has no rex W. I don't understand. Maybe when I generated, I don't think, yeah, like when we generate, we don't do a switch on the size. We just pop them in there. I don't get it, people. Let's just fill out the rest of these while we're here. Okay, so the 1 byte is OFB0. Okay, here's a clue. I don't understand the difference between these. Like, that's some kind of like bullshit thing. So OF B0 mod RM, right? Let's do a 1 byte version. I mean, we're gonna like fail, but we should terminate, right? Because we overflow like a zillion times, which is why it says failure. But okay, that's weird. The first one says success true now, but we don't terminate. Don't get it. Don't get it. Okay. We're going to factor this out. And the lock prefix. Okay. OFB0, OFB1, OFB1. Okay, so what? I seem to remember something weird about 16-bit mode. That's like a different prefix, right? How does anyone remember OX66 prefix to change op size of 16 bits? Okay. Yep. Oh wait, that's a different 16-bit operand size prefix. Yes, I've done that before. Okay. Now it doesn't matter because the 32-bit one doesn't work anyway. But yeah. I mean, let's go back to our simple program. We're going to put 42. Okay, so we're returning true. There's like we're not ever starting threads. We're returning true, and we're not even doing the frickin' thing. That's upsetting. Okay, let's go back to 64, verify that that works. No. Really? We broke 64-bit. How did we do that? We had it working. Let's see. Lock comp exchange, RDI, RCX, set EDL. I mean, okay, RAX, RCX. These don't sound right. Oh, I screwed, okay. I screwed this up. Right? I was like, oh, isn't it weird that I don't need that? I bet I do need it, and I'm not sure why I decided I don't. All right, well, that didn't work either. Frickin', let's actually look at what this is. Yeah, that's an offset. Who calls that I... Yeah, we're calling register offset there. Oh, because this is a constant. I was confused. I must have looked at that one line. Yeah, okay. Okay, this was a learning experience. All right. Did I rebuild the compiler? I don't even know. No, I didn't. That's why it didn't work. You have to rebuild the compiler. There we go. People ask me how you succeed in the game industry, how you surpass all the trials and tribulations. And I say, make sure you rebuild the compiler. All right, we failed because of the 42. We'll put this back to 0. All right, good. 32-bit. Good. Okay, 16-bit is going to be a problem because we're going to overflow. But we should overflow the same. So this is 18928. And this is 18928. All right, and 8-bit. Should overflow the same at compile time and runtime. Minus 16. Minus 16. It is Miller time. The ASM said it was a normal load, not a zero extend load. Yeah, well, the 64-bit will not be a zero extend load because there's nothing to extend into, right? And that's what we were looking at. So move extend indirect here when size is 8 just does a move, which is why I was able to factor it out. I could factor these mod RMs out at the bottom. I mean, yeah, whatever. Whatever, guys. We have an intrinsic. We did it in 2 hours. Okay, so now the thing that we were going to check, there was a cleanup that sure are lots of cleanups. It was in the other intrinsics, wasn't it? Yeah, it was here. I thought, oh wait, no, that was in the bytecode runner. This one. this one, which we also did here. So I'm going to test that. If we're actually only using the low 8 bits, then this shouldn't matter. I mean, it's just a Boolean in this case, so it's hard for me to know. Yeah, let's put it back to something that'll pass. All right. Well, let's look at the other one. Again, I'm pretty sure so this one probably doesn't really use memcomp, but the game does. Let's see if we broke something. Don't forget that thing you told us to remind you to remove. That's what that was. Hey, look. I'm playing a game. We're going to have to fix this choppy frame rate during playbacks. It's on my list. All right, well, we apparently have an interlocked exchange intrinsic, or compare and swap, or whatever you want to call it. It's our first official threading intrinsic. That's party time. It's excellent. I'm sorry, people, that I'm going to break the build on Windows or on Linux. So we're just going to do this, and we're still breaking the build on Linux and Mac OS. Yeah. All right. We can crank the counter up some more again. You should be able to sync, bool, compare, and swap with the same args everywhere else. Oh, that's like a POSIX version or something, or not POSIX, but Unix people post POSIX world. Except it returns a bool. Yeah, well, ours returns a bool anyway, so that's all that we need. I kind of want to order some Uber Eats now. I think, so what we're going to do is, this is going to be Miller time. We're going to check this in, and then we're going to switch to gaming stream. Let's also, we're going to do a debug build of the compiler and make sure that that doesn't assert. Good thing we're attempting to index a nil value all the time. So we're going to use this intrinsic in debug mode. Where's my Uber Eats? I need some eats. I'm tipping the guy who delivered me something like a month ago. I'm sure it was fine. Okay. Citrus Club. I like that place. Are they open late? $10 p.m. Why is Uber Eats giving me that? No, I don't want to bother people who are about to close. Wild pepper. Oh, yeah. I didn't realize wild pepper's on Uber Eats. They're also... Oh, man. What? I'm just trying to get something that's not about to close, that's also not McDonald's. Okay. I was about to click on something and it just changed everything and removed it. Okay. Gotta get sweet potato fries. All right. All right, we're getting our food needs taken care of. Okay. Looks like I could use it, ignore large struct. No, that's not actually, this is not actually something that we intend to be there, and it's not actually what you think. That's not the size of the struct, it's the size of our debug info or runtime type information for that struct. And the reason it's that warning is there is just because I was profiling these things as I was optimizing them. And we probably want to optimize them more. So I left that up. But this is probably not something that you would get in the shipping compiler as a message unless you turn it on explicitly or something. I don't know. We'll figure it out. Whoops, we got the Heisenbug again. Someday I will fix that, I swear. I totally swear. All right, so we built a debug compiler as well. Let's do that. It's not asserting. Great, it's Miller time. Commit. Add an intrinsic for compare and swap. Breaks. Build. Whoops. Why am I committing the game? It doesn't make sense. Breaks build on Linux. No, sorry. Okay. Bam. I'm going to send an email. I just broke the build by adding an intrinsic for compare and swap. This needs LVM support as before, but it also needs a specific support in bytecode runner.cpp. Could have done a single source thing that is too ugly. So what someone in chat was saying what the thing is. Someone in chat, a fine upstanding member of chat says that you can use, whoops, sync bool compare and swap on both Linux and Mac OS. But you actually need to do less work in that case since that returns a bool, but the code okay. That's great. Miller time. Are there any questions about what we did today? Easy mode is not beating the game. Yeah, Witness 2 has easy mode. Come on, guys. You got to save something for the sequel. Okay, questions. Technical questions about what we did today. We'll do a couple off-topic questions if there are no on-topic questions. I'm probably going to export these couple of streams today. Did I want to remove the XFFF? Didn't I get rid? I guess I didn't get rid of it. Okay. Thanks. I thought I did, but I was forgetful. Have I talked about Baba Is You? I thought I played that on stream already some, didn't I? Or did I not? Pretty sure I played it a little bit on stream. Fix unnecessary code. Remove. Is the nickname Naysayer based on Albert from Twin Peaks' I Love You, Sheriff Truman speech? Not consciously, but it could be. I mean, that's one of the most memorable scenes from that entire show. So maybe that's where I got it from without knowing. What do I think about Zachtronics games? Well, several of them are on my good games list, which you can go check out if you are interested. Do I think it would be wise for someone like us to invest in technologies like Stadia and other streaming game services? Well, you know, if it's successful, then having another place for people to play our games, if they want to play them there, is probably not that bad of a thing. Why am I jet lagged? Because I went to Asia for 2 weeks, and I'm currently on Singapore time, except I seem to have recovered pretty good. So it's just, I'm a little bit disoriented. I'm going to make sure I stay up till like 11:30 tonight, and then we'll see. Have I considered doing more videos like the motivation video? No, because I don't really have anything more important to say than that. Like I said in there, the best things that I know, they're still the best things that I know, like 2 years later or a year and a half later. Singapore seems really dope. Why would you move out of Singapore? What's up, Hummus? You missed our thing that we did. We did a thing. In just 2 hours, we did a pretty good thing. We're going to play some games soon. Company closed its Singapore office and you moved to Tokyo. I mean, Tokyo's cool and all, but Singapore is pretty good too. And they speak English in Singapore. I actually never saw Crazy Rich Asians. Maybe I should see it now that I've been to Singapore. Can be a bit claustrophobic once you've seen the whole country. Yeah. How about Hong Kong? I've never been to Hong Kong. I feel like there's not that much English in Hong Kong. I think if you had a family, you would prefer Singapore. How long ago did you move out of Singapore? Because, like, they're doing stuff there at a crazy pace. Like, even Singapore 5 years ago is probably kind of different from Singapore now. It's like crazy. Friend and streamer follow recently went through The Witness, seemed to love it a lot. Well, I'm glad. Right on. Wondering if we have a run command that does automatic compile on save. At work, we have a custom compiler controller which recompiles whatever files which are included in the project. Oh, yeah. I mean, that's been on the list. In fact, I think I gave the idea to Casey to do that. I mean, I was discussing with him that I was going to do that, like, before he started Handmade Hero. Maybe he did it independently. I don't know. But, yeah, like, it's just base language features are just more important right now. Yeah, dude, the Marina Bay stuff in Singapore is crazy. Maybe all that was built 5 years ago. Like the frickin' like rainforest jungle dome stuff that they have down there. It's like so nuts because you're outdoors and it's like, you know, 92 degrees Fahrenheit at night. And then you walk into this dome and it's like chilly inside this giant, giant dome that they're totally air conditioning. It's very impressive. There's a lot more Mandarin in Hong Kong. Yeah. What do you think is fun to do in Singapore? There's lots of stuff. You got to go. Okay, the Jungle Dome stuff that I just mentioned is cool. Marina Bay Sands swimming pool is cool. I should tweet some pictures of that now that I'm not there and can't be stalked. Ha Par Village was amusing. Singapore City Gallery was cool. That would be a cool stream to do an auto compile on save. It's probably more than one stream, honestly. It's probably a series. You recommend trying to live without air conditioning at night? I don't recommend that. I don't recommend that at all. Ha ha ha. Just waiting for the eats to get here. Okay, questions. Who has real good questions about what we are doing? For someone writing multi-threaded code, do you think it's important to have good glass on the ideas presented in Weight-Free Synchronization by Herlihy? I have not read that. Is that the one from the 90s where he goes through all the algorithms? Probably a good idea. I don't know. Did I ever find a laptop that doesn't suck? No. Yes, it is. You'll also take that as a no. Well, I don't know. I mean, I actually, to be honest, don't have a good picture in my head of lock-free algorithms just because I've never really done them that much. I mean, I could probably try and design some and think my way through them from first principles, but it's probably easier to just look them up, and some people probably have come up with faster ones than I might do. Null. Anyone in chat know of a laptop with a decent to nice keyboard? That is the eternal question, or one of the many eternal questions. You think it's where compare and exchange came from? Let's look that up. It wouldn't hurt me to read that paper, actually. Synchronization, whatever. All right, we will read this. Oh, what a bad quality scan. ACM digital library not responding. Gee, I could buy it from the ACM so that I don't get a poop quality copy. I guess I have to read the poop quality copy. Same poop quality copy. Oh, different. Lower res. What is wrong with people? Nobody cares. Well, we have low res or higher res, but maybe it's not really higher res. Why is everything so bad? This one's, I guess, more readable. Could paste the ACM article into Sci and get the non-poop version. How does that work? Search temporarily unavailable. All right. Hey, it's the poop version anyway. ACM charging money for terrible quality. Thanks, ACM. You're hoping to write some sample code for your distillery project. Is there a way to get on the early beta for educational purposes? Maybe. I mean, if you just DM me on Twitter and we could talk about it. Because it's still an in development language, I don't want to like encourage people doing stuff to use it. But, you know, if you want to, I'm not going to discourage you. Except, well, when it's out, I'm not going to discourage you. What else do you think a new approach for in programming or tech? Basically, everything is terrible right now, right? Operating systems are bad. The World Wide Web is awful. We just need to push the reboot button on every technical decision involved in the World Wide Web. Like, web development would become so much more efficient if we just did the things in the way that we knew how to do them in the 1970s instead of the goofball way they were done in the 1990s. We would make the entire software industry tremendously more efficient by doing that. Like, not 10% more efficient, like 3x to 8x more efficient. It would be crazy. But nobody's ever going to do that, so that's sad. So instead, you get to hire 8 times as many web programmers as you need. I don't know. Everything is pretty bad right now. Have I seen Kit Lang? No, I haven't. That's a bit negative, don't I think? I mean, really everything. Yeah, pretty much everything. I mean, there's some games that are okay. Even those are not as good as they should be, but that's because they're built on tools that are not very good. How did programmers code in the 70s? It's not how people programmed, because there's ways in which it's possible to program now much better than people did in the 70s, just because we have computers that are faster and we can do things that are not a big deal to us today that would have been very hard back then. The difference is that people in the 70s knew what the fuck they were doing, and nobody now knows what they're doing. It's embarrassing. That's really the difference. Like the 1980s is sort of the decade when computing started to get taken over by bozos, and then starting around mid to late 90s, it became all bozo all the time. It was bad. What about those of you that program both the 70s and now? Well, I mean, maybe you know what you're doing. I'm speaking about the industry in general. I'm not saying there are zero people who know what they're doing. I'm saying that almost all programming today is pretty clueless. That's what I'm saying. I want my food to get here so we could swap to gaming. Oh, it's out for delivery. 6-minute ETA. Where's this guy going? Bro, you're going... somewhere totally irrelevant to delivering the food to me. What's an example of not clueless programming? Well, so writing a program and knowing what the program does, including all the procedures that it calls, like what they actually do. Like that's just not how anything works now. And then you go to soft, goofy languages like JavaScript, and then like people don't even know what their variables are. They don't really know if they're declared or not. Like people just don't, I mean, yeah. Do machine learning now? Well, that is true. That is a case where people don't really know what things are doing. I mean, so let's be clear about this. Like, what percentage of machine learning projects do you think are even doing the right math? Versus like, oh, we plugged some stuff into a neural net library and I guess it works. Like we kind of got some output that we're using. Like I guarantee a lot of those are just screwy and wrong. Happens in graphics even, but in machine learning where you don't even have a good visualization most of the time, it's like, ugh. Why did this guy go across Market Street? Okay. He's actually on my side of Market Street now. even when you write the net and understand the math, it's still a crapshoot. Totally. And it's because it's just so easy to make a mistake, right? Like, there's plenty of places to make mistakes, and the mistakes are not easy to visualize. So you just have to be really diligent and at many steps make sure that there isn't a mistake. Like, what percentage of published machine learning research papers are just doing the wrong math than what they think they're doing? I bet it's high. Knowing graduate students, it's probably at least 2/3. Do I have any thoughts on how computer networks in general could be improved, in particular the various layers of the communications? Well, I don't buy into this idea that you should have an 11-layer burrito to do communications. I mean, your network protocol should be a library that you link. It shouldn't be in the kernel, right? If that were true, then we could have a lot more experimentation and freedom than we have today. And things would progress rapidly. But because things are in the kernel, they're just frozen. And they're not just frozen, they're also slower than they should be, because you got to call out to the kernel to send a damn network packet. All right, I'm going to go grab my food, and I will, well, we'll give it another minute before I go out. Will automation really change society in a way that we haven't dealt with so far? I think the level of automation we will be seeing is much higher than we have seen in the past. It's really high. Most ML papers do not reproduce, and they only work because the implementation had subtle bugs or picked RNG seeds and hyperparameters to make the algorithm work. Totally. That is what I think as well. Business software checking the value of a Boolean before setting it from a checkbox in the GUI, and the file the bug is in has not been edited in 5 years. Okay. I mean, I'm not sure what the bug is from that description, but all right. All right, I'll be back in a couple minutes. Please entertain yourselves. So what was the deal with those people who were spamming chat? What channel was that? Anyone know? so hungry. I think the raid was from R.W. Grimm. Well, that is not our nemesis, Grimm's, so I don't know who it is. All right, everybody. Here's what's going to happen. I'm going to hit stop on the stream just to split the VOD. And then I'm going to start the stream again about 1 minute later or less. And it'll be a gaming stream. And you guys can watch me attempt to game while tired. Bug was essentially the checkbox had no effect and the value was always false. No one seemed to notice or care. Right on. All right. Thanks for coming to the programming stream. We will be back after these messages.